Welcome to 288W. I am your instructor, Robert McMillen, and we are in our Module 4 presentation. And the last module, Module 3, was our hardest lab, so it's only fair to follow up with Module 4 being our easiest lab. So we're going to talk about DNS and troubleshooting tools and things like that that make DNS work. And then in our lab, we're going to create some DNS zones and some host records and explain about how that all works with Active Directory. So let's take a look here. So DNS, although DNS is not that complicated at first glance, to master it can take many years, and it is something that if you are really good at, you'll be well sought after when you go to look for a job. All editions of Windows Server 2012 include DNS Server because without it, it just doesn't work right. DNS is the name resolution service for Active Directory. It's installed automatically when you install Active Directory. So when we installed Active Directory on DC01, it automatically added that to it. It does both forward and reverse lookup queries, so you can look up by name and get an IP, or look up by IP and get a name. DNS provides a way to cache DNS information to reduce the number of queries that are required. And the time to live is the amount of time the DNS information is cached. So once the time to live, the TTL, is over, then it has to look that information up once again. So the DNS namespace is a hierarchical tree in which each node and leaf is separated by a period. So if you go to www.cnn.com, for instance, you have a dot between each one, which is really a period. The first level of the tree, which is the top level domains, is all the way on the right. So .com, it goes from right to left. So .com, .net, .org, those are top level domains. And they're assigned by the internet, by ICANN, actually, who is responsible for defining all of the different domain names. And they're adding more and more like crazy. If you want to see what the current list is, just go to this website. And there it is. They have added a lot. It's not just .com and .net and .edu and .org anymore. Okay, so let's go back to where we were. Public and private namespaces. So a public name would be .com, .net, etc., etc. But then there's internal names as well that we're going to go over in just one second. All right, so name resolution using DNS. You have zones. Zones are created, which are basically just domain names, and you create host records inside those zones. So zone is the portion of the DNS namespace that's controlled by a DNS name server, or a group of them. Zones establish the boundaries within a particular name server can resolve the requests. So there are resource records stored in a distributed database, DNS name servers that are responsible for maintaining all those zones, and DNS resolvers running on clients. So those are the three main components of DNS, and that is a quiz alert. So, internal DNS server requests. So let's say you are in a workstation and you want to connect to a server. That's considered an internal DNS server request. A public DNS server request is if you're on a workstation behind an Active Directory domain controller and you want to get to a website like yahoo.com. That would be a public one. So your DNS server internally would handle both of those requests. One request would be redirected internally and one would be redirected externally out to the internet. So a DNS client sends a DNS query for a local resource. The DNS server checks the database and forwards the request to the authoritative server. So that's one of the things to remember, and that is a quiz alert, is an authoritative server. That is whoever's in charge of maintaining the DNS zone. Now, if it's Active Directory integrated, like our widget LLC.internal, then it means that any domain controller is going to be authoritative because they're all equal. And in our case, we only have one in this particular class. But in our 279 class, we actually had two. So the authoritative server sends back a request to the local DNS server, and the response is then forwarded to the client. So if I pull up a command prompt right now, and I ping yahoo.com, it's going to go out to the authoritative server for Yahoo, and it's going to return the address. Now you can see here that it's a IP version 6 address. It's not always going to be an IP version 4. And we're going to do more of those examples later on. So as I mentioned earlier, the external DNS request is the DNS client sends the query to the internet resource. The DNS forwards it on to the root server and then sends it back to the client, which is what we just did with our command prompt. So here are the common names, or the common types of host records. They're called common resource records, but these are the common types of records that you are going to create. And we're going to be doing some of these ourselves here. So the first and most common one is the host record, or the forward lookup record. And in our last example, that's what we did, was we did a forward lookup, a yahoo.com to IP address is a forward lookup. Then there's CName, which is an alias. So let's say company A buys company B, and so when you go to companyb.com, you want company A's website to show up, and you no longer want the URL at the top to say company A. I'm sorry, company B. You want it to say company A because that's the new owner of the place. So you can create a CName, which creates an alias. So if anybody types companyb.com in a web browser, they'll get companyaa.com as their web page, and what will show up in the web browser. So that's what a CName record is. An MX record is mail record. So if you want to know where the mail server is for a domain to send email to someone, then it does a lookup for the MX record to find that out, and then sends the email off to that particular record. Name server record, that's whoever has the authority over that particular zone. So we're going to do an example of that in our lab. If you don't have authority over it, it doesn't mean you can't resolve it. You can still resolve it, but you can't make any changes to it. And that is an alert in our lab. PTR record is a reverse lookup pointer. So that's the opposite of the one that we did. So we did our forward lookup here earlier. So if we just copy this address, edit copy, and we do a ping -a and paste, then you can see it resolves with yahoo.com. Now it shows us more than just yahoo.com. It shows us all these other names. These are subdomain names off to the left. So this shows us the actual server name, not just the domain name. So it gives us a little bit more information. Start of authority is the authoritative name server for that particular zone, and you also, which goes hand in hand with our name server. Then SRV records points to a particular service in the domain, and of course there's a lot of those in Active Directory. So service records are important for Active Directory to work properly. So there they are, SRV records used to locate Active Directory resources organized by function. So you've got DC, domains, GC for global catalog, and PDC for PDC emulators for prior to Windows 2000. So there's different types of zones you can create when you go into DNS Manager, which I will show you here shortly. And when you're given the option, you could create a standard primary zone, a standard secondary zone, an AD integrated, and a stub zone. Each of these 4 DNS zones can be created for forward or lookup reverse lookups. So let's talk about what these different zones are. So the standard primary zone means that if you create that, you are authoritative for that zone. I mean, you can create host records, make changes to it, that kind of thing. A secondary zone is basically a copy, a read-only copy of the primary zone. So in here, you can still use it as a DNS server, but you cannot make changes to it. Only the primary can. Active Directory integrated goes hand in hand with the standard primary. When you create the standard primary, you're given the option to create an AD integrated zone as well, which is just a little checkbox. And what that does is it replicates that zone to every other domain controller, where it can also be a primary authoritative and be authoritative for that domain. A stub zone is kind of like a secondary zone, except for the secondary zone leaves a copy of the entire zone on the server, whereas a stub zone, it doesn't do that. It's a read-only read-only zone, but instead of keeping a copy of the entire zone, what it does is it relays requests off to the primary server whenever one is made. So the nice thing about a stub zone is if you have a primary server that changes just constantly, then it doesn't make sense to have a secondary zone on there, because there would be replication going on and slowing down your network. So if you have a network that doesn't require a lot of changes, a secondary is the way to go. But if you have a network that changes constantly, then you want to go with a stub zone, so it never has to worry about all that replication. DNSSEC, this is going to be on the quiz. Digital signatures. It's encrypted using private key encryption on a per zone basis. In private key encryption, there's a public key and a private key. So this is very similar to any other type of encryption that we use nowadays, such as going out to the internet and buying something on Amazon.com. You know, we have a public key, we have a private key, we put those together, and that's where we get our certificate. The public key is stored in a signed zone in the form of a resource record, and the zone's private key is not stored in the zone. Is used only by the name server to sign the related zone or parts of the zone. So it adds security, it adds encryption to our DNS. So you know where it came from. Dynamic updates and security. There's two different types of dynamic updates. There's secure updates, and this is an option when you create your zone. You can make this change. So it ensures that only a client that created a record can update a record. And then there's non-secure updates. There's no way to ensure that only a client created a record to update a record. So sometimes we use these non-secure dynamic updates for servers that we trust but aren't necessarily Microsoft Windows servers. They might be older Windows servers that don't handle secure updates, or they might be Linux or Unix servers that just don't work well with the Windows security. So in order to get those to work properly, you might have to turn non-secure updates on. And then standard zones, which is a default setting to allow both secure and non-secure updates. So it'll use secure when it can, and it won't if it's not available. So here's the security issues that you have to worry about as an IT administrator running a DNS server. You have to worry about IP spoofing. That's where somebody pretends to be somebody they're not. So that generates IP packets containing valid IP addresses. It looks like the packets are coming from a valid IP address, and it allows the attacker to gain access to the network. Pollution of the DNS cache. This is actually a little bit more common, and it happens a lot with viruses. So when you go to look up a zone, it's going to cache that information for a certain amount of time. So if you need to look it up again, it doesn't have to go out to the internet to find it. Well, it creates this cache file, and the cache file has a certain amount of time to live, as we talked about previously. So if a virus comes in and pollutes that cache and says, hey, yahoo.com's not at that address, it's really at this address, which is a website the hacker controls, then you could end up going to a website that looks like the website you want, and you put in secure information that ends up allowing the attacker to steal your data or your files. Forest root zones. In this zone, Active Directory creates an SRV or a service record that are used when clients are looking for a particular resource. So you've got global catalog servers, LDAP servers, and Kerberos servers. So let's talk about that. Global catalog is what when you create an Active Directory server, the very first server is a global catalog server. And you can have multiple ones of these, but you have to have at least one. And that basically has a copy of Active Directory on it. An LDAP server does the authentication. It could also be the same server as the global catalog, or it could be a different one. It's up to you. So this LDAP server, lightweight directory server, basically, if you say, hey, does this user Tom exist in this database in Active Directory? And the LDAP server will come back and say, yes, Tom is here. This is his username, and this is his information. So an LDAP lookup is something that's used both in Windows servers and it can also be used in Linux and Unix as well. Kerberos is a way of authenticating a user. When they put in their username and password, a Kerberos database will go in and say whether or not that information is accurate, and it will encrypt the data as it streams from the client to the server. Now, when you create an Active Directory, you're also going to see a zone that gets automatically created called the _MSDCS domain. If you don't see that, then Active Directory won't resolve properly. So if anybody accidentally deletes that, or it gets corrupt and doesn't work right, then it could definitely cause Active Directory to not work correctly. So there's several ways you can manage a DNS server. One is using the DNS Manager, the GUI tool. Another is you can go by command line. There are some additional scripts that are written into Windows using the PowerShell, which is also a form of command line, but you can run scripts to do many things at once. Computers use reverse lookups to find out who is contacting them, so you can see who it is that's trying to get this information. And this is so they can display a host name to users rather than an IP address. A conditional forwarder is a little bit different. That's when you have, say, multiple forests where you're trying to trust more than one forest or domain in your network. That happens a lot in bigger organizations. So you can tell your DNS name servers, your DNS servers, that if they see a request for a specific domain, they should not forward it out to the public. They should forward it to another internal server. So that can definitely come in handy in larger organizations, as I mentioned. All right, maintaining and monitoring DNS. A key task you might need to perform includes configuring default application directory partitions and replications, setting aging and scavenging, which we're going to talk, it's going to be one of the questions in the lab, and configuring logging and checking event logs. So all these things you definitely want to look at on a regular basis if you are an IT administrator managing a DNS server. And here's some of the tools you can use. You can use NS Lookup, which we'll be doing in the lab, as well as ipconfig. Now, we did an ipconfig previously in the last lab. You had to do a screenshot. But there are several switches you can use, such as ipconfig all, which shows all the IP addresses on your computer, not just the one network address. Flush DNS, which gets rid of the cache of DNS files and starts them all over again in case you have an update and you want to get that update immediately. Releases your IP address from DHCP and renews it again in case you need to get a new IP address for whatever reason. And register DNS, that will do is it will register your DNS IP address into the DNS server, so that way your computer can be found right away. Sometimes you have to troubleshoot the DNS server. Actually, a lot of times. Anytime you have slowness on a network, the first thing I look at is going to be DNS. Active Directory replication of changes to DNS zones is automatic. By default, it changes every 180 seconds, which is 3 minutes. You have to check the server's cache. If the problem with DNS is that you think the server has stale records, then you can check the zone information by running this command, DNS CMD server name zone print. You can force a server to clear out its cache memory of resource records via DNS Manager, or use the following command, the DNS command. I'll show you how to do that in the GUI. So our objectives for this particular lecture were the introduction to DNS and public and private namespaces, some zone information, secure transactions, and some DNS tools. So now let's actually do some of these things in our lab. So we're going to need DC01, Router 01, and Client. So go ahead and boot those guys up, and we will start working on some of the different parts of this lab. Let's start off by going to our DC01 and go into Server Manager, Tools, and inside Tools we will choose the DNS Server. And all it says is DNS, but it's the DNS Manager. All right, let's expand our forward lookup zones. And you can see we've got a couple, and because it's Active Directory, we see an MSDCS and a regular widget LLC.internal. So you can right-click on either one of these and go to Properties, and you'll see similar settings. So we have information such as our start of authority and some refresh intervals. That's going to be a question on the lab. Name servers. You can have a list of all the different name servers, and we only have one, of course. Zone transfers we talked about earlier. You can allow a zone transfer to any server, which would be not quite secure, or only servers in the name server tab, or only to the following servers. That's up to you. There's a WINS tab in case you want to do a WINS lookup for older servers. There's a security tab, which tells you who has access and what their access is. Of course, the Everyone group has the read-only, so they can't make changes. So it gives you an idea of some of the different information. Here's our dynamic updates secure. So when you create a zone, you can see the different types that you can choose from, and you can go in and change those afterwards. So if you see type Active Directory integrated, if I want to, I could go in and change this from primary zone, which makes it authoritative, and store an Active Directory. I could change that to secondary zone, which is a read-only copy, but then I'd have to have another server that I'd be getting that read-only copy from. And in this case, I don't have another server. And in the stub zone, which we also talked about earlier. So we are going to create a reverse lookup zone. This was our forward lookup zone, names to IP addresses. I showed you a reverse lookup, which was an IP address to name. So now we're going to actually create one in our Active Directory. So, in our DNS server. So we're going to right click and choose New Zone. And we'll choose Next. And we're going to leave the default primary and store an Active Directory. Next. And we'll leave the default to all DNS servers. There's only one, so it's not going to affect very much. And this is going to be an IP4, which is the default. And we're going to put in our subnet, which is 192.168.0. And we're going to leave these as defaults for now. And we're going to click Finish. So we haven't actually created any reverse records, but just because of the fact that we created the zone, it creates the start of authority and the name server records by default. So let's go to the forward lookup zone and take a look at our DCON record. Let's right click on that and go to Properties. So we have an option here where we can update the associated pointer. Click there, click Apply, and then we'll go back to our zone and we'll hit refresh, and there it is. There's our pointer record. We can also just right click on here and choose New Pointer Record and accomplish the same thing. So let's do that right now for router 01. So let's right click, New Pointer, and router 01 is .1. So you can see it appended that to our FQDN. Click Browse, and we're going to change this here. Double click, forward lookups, router 01. Click OK, and now there's our reverse record for router 01. All right, let's go over to our client computer. By the way, if you want this, if you're in Windows 8 and you want that start button and you haven't gone to Windows 8.1, I just went to nite.com and clicked the classic start button. If you update to 8.1, then you'll get the start button anyway. All right, so let's take a look here. So we want to open the command prompt, and let's just take a look at ipconfig display DNS. And there we have it. It shows us the DNS server and the IP information. All right, now we're going to do an NS lookup command, which is name server lookup. And it shows us basically the same thing. So the display DNS showed us the forward lookup, whereas the NS lookup did the sort of the reverse lookup. But they both ultimately show us the same information. Now there's a few more tasks for you to do on your DC01 and your client, which I'll let you go ahead and do. In the meantime, we're going to go ahead and create on router 01. We're going to install the DNS role, and I'll show you how to create a secondary zone. So on router 01, we'll just go ahead and click on DNS server. So we're not going to put Active Directory on it. We're just going to put a DNS server on it. And when it's done, we'll create a secondary zone. While we're waiting, let's go back to DC01, and we're going to go to our zones here, and we're going to create a new zone. and it's going to be a primary zone, and we're going to call it widgetllc.com, not .internal. So this will be for our public. There's widgetllc.com. And we're going to right click on that guy and go to properties, and we're going to go to zone transfers, and we're going to say to any server. Not the most secure way of doing it, but it's fine for this particular lab. And we're going to go back to router 01, and when this is done, we're going to create a secondary zone that will download a copy of what's on the widgetllc.com. And it looks like it's done. Now, I did not follow the lab exactly on purpose, so that way you could go in and do it the way the lab said. But it's not that complicated. Otherwise, I'd walk you through it a little bit more closely. So, for instance, I didn't choose, in the lab, you're supposed to choose the exact IP address of the server to do the zone transfer, and then you're supposed to do a couple of other changes as well. But I'm not going to walk you through exactly the way it is, but you can go ahead and follow the directions. So let's go to DNS. You can see that it's installed, and then we'll go to Tools, and we'll open up DNS Manager. And we'll create our secondary zone. And the reason I do that is because this can be a little bit tricky sometimes if it's not done right. So let's go ahead and right-click on our new zone. Right, this is our router 01, so there's never been a zone on here before. So that's why there's nothing there. And instead of choosing a primary, we're going to choose a secondary. And we're going to call it widgetllc.com. And it's going to say, hey, where is the master? Well, the master is on DC01, so we're going to do 192.168.0.5. It resolved it. Good. And finish. Now, you can see here, this is one of the problems that can happen. It says, hey, I cannot communicate with DC01. I can't seem to get this zone transfer to work. Sometimes it's as simple as just hitting F5, and that's all it was. So hit 5 to refresh, or right-click and refresh, and it finally did replicate that zone. You could also right-click and choose Reload, Transfer from Master. They all kind of do the same thing, and it will force a synchronization of that secondary zone from the primary zone. Now remember, this is a read-only copy, so you can't go in here. You can't go in here and create any host records like you could on the primary, and that is one of the questions on the lab. So that's our secondary zone. So as we finish up this short lab, don't forget to do all your screenshots. A screenshot of DNS Manager and router 01 showing the records for widgetllc.com. Can you create a new record on router 01? Well, we right-clicked and we could not. So why or why not? Lab reflection. Did you have any problems? What did you learn? What is the NS Lookup used for? We actually did some NS Lookup commands. Response, let's see, we've got for the adaptation. So you're given a little scenario here of scavenging records. And so provide instructions on how to enable scavenging, aging and scavenging on DC01. And you can find that in the book or online. So that concludes our Module 4 lab, and good luck on that. I don't think it's going to take you very long. It's a fairly easy lab, but it's very powerful and important information. So we look forward to Module 5.